Hello everyone. Welcome to today's Bentley Bridge SIG meeting. SIG stands for Special Interest Group. These meetings are held basically to communicate with Bentley Bridge product users with respect to what we are doing with our products and address any questions you may have. As you can see on the screen, all those are attending this presentation will receive one Bentley Learning Unit. If there are more people attending with you under your name, all you need to do is send in their names and contact information in an email, reply to the email that you'll be receiving shortly after this presentation, and we'll send the learning units to all of those attending with you. The schedule for all of the SIG meetings is available at the URL shown on the screen, and these are complimentary. So please spread the word in your offices and invite your colleagues to attend. My name is Shri Bhide. I'm the Director of Product Management for our Bentley Bridge products. Before I get into the Bentley, the range of products that we offer, today's topic is Leaf Bridge Steel. What you'll be hearing about is what new features we're adding to the upcoming release of Leaf Bridge Steel, which will be released in early June. So just an overview of new features and short product demos. And then we'll follow that with questions and answer session. You can ask questions on any of the topics presented today or any other questions you may have with Leaf Bridge Steel. So these are the various Bentley Bridge products. Leaf Bridge Concrete, which is for everyday concrete bridges. Leaf Bridge Steel, with today's topic of presentation, and that's for everyday steel bridges. RM bridges for complex bridges and advanced analysis. Large bridge is used for load rating all kinds of bridges in use today in the United States. The everyday bridges, which it includes basically all three materials: steel, concrete, and timber, and it does load rating, according to all three design codes: ASD, LFD, and LRFD. And finally, OpenBridge Modeler. It's a 3D intelligent parametric modeling of bridges. It's software specifically designed for this purpose. It is interoperable with all of our Bentley products. And it is microstation based. So you do not have to be an expert user of microstation. You can create 3D bridge models literally in minutes. As I said earlier, OpenBridge Modeler is interoperable. It connects with our Bentley civil applications, the Geopack, InRoads, MX Road, and now OpenRoads Designer. We can build our models on top of the alignments and profiles created by civil engineers. This model can then be taken to Leaf Bridge Concrete or Leaf Bridge Steel for analysis and design. The model information, the updated information from the analysis packages can be brought back to the OBM model. This model can then be taken to Pro Structures for detailing. Of course, this analytical connection is also there for RM Bridge. Since this is a microstation based product, you can create all sorts of cross-section, elevation views, and drawings straight into OpenBridge Modeler. A list of upcoming SIGs, as I said earlier, these are all, the list is available on the URL shown at the beginning of the presentation, but here is a snapshot of what's upcoming. Next month, we'll be talking about seismic design using multiple mode analysis and response spectra, and that's in Leaf Bridge Concrete. This is an exciting new feature we are adding to Leaf Bridge Concrete, and we'll present that to you in the next SIG meeting. So now, before starting today's presentation, I would like to introduce today's speaker, Burak Boyachi. He's the product manager for our LeapBridge steel product. He's a registered professional engineer. He holds a bachelor's degree from Middle East Technical University in Ankara and a master's degree from the University of Massachusetts. Burak has over 7 years professional experience. So with that, I invite Burak to start today's presentation.
Hello everyone, my name is Burak Boyaci. I'm the product manager of LeapBridge Steel, and today I'm going to talk about what's new in LeapBridge Steel in the upcoming release, which will be released in early June. I know most of you are LeapBridge Steel users, but for the ones who are not familiar with the product, I'd like to start with a brief video.
LeapBridge Steel is the complete package for the design, analysis, and rating of steel bridges. And by complete, we mean the software addresses all fundamental areas of steel bridge design, from modeling to code check compliance. So let's take a look at just a few of the benefits of using LeapBridge Steel. Modeling, analyzing, and designing steel bridges has never been easier or quicker. Using LeapBridge Steel, existing civil data like alignments, profiles, and DTM data can be imported from Geopack, En-ROADS, or MX Road to start a new bridge model or models, resulting in a distinct productivity advantage from the start. Building on imported civil data, a bridge can be quickly and easily defined in terms of slabs, girders, cross frames, piers, and/or abutments using LeapBridge Steel's parametric modeling interface. Changes made to the model are instantly reflected geometrically and in load cases applied to the model. These productivity advances result in quicker turnaround, shortened project schedules, and the ability to review multiple design alternatives. Using the completed bridge model, dead and live load analysis is quickly performed, and the results are viewable graphically and in report format. LeapBridge Steel transparently uses the STAAD Pro engine for all structural analysis. STAAD models created by LeapBridge Steel can be used for more advanced analysis directly in STAAD Pro. Performing design calculations that are compliant with the AASHTO bridge design specification is extremely important to the bridge designer. LeapBridge Steel is compliant with the 6th and 7th editions of the AASHTO LRFD bridge design specification. High-quality reports are the end product of this phase of the design process, which shows all pertinent articles and equations that are checked by the system, providing the engineer confidence that all calculations are compliant and removing the black box effect. From start to finish, LeapBridge Steel provides a data-rich environment. The bridge model plus analysis and design data can be used for many extended purposes that increase productivity. This includes preliminary and final drawing preparation, public hearing presentations, and construction staging.
Okay, as you see, it's very handy, it's very easy to use, and very helpful for your production, for your designs. So moving on, as again, some of you already know, the current analysis and design capabilities of the LeapBridge Steel is line girder and grillage analysis for eye girders and design check for eye girders. Basically, we weren't covering top girders so far. We had only two options for the analysis, line girder and grillage analysis, and then design check for eye girders. So what's coming in LeapBridge Steel Connect Edition V17 in early June is that we have some major enhancements and minor enhancements. Major enhancements are the 3D finite element analysis for eye girders and top girders. As I mentioned in the previous email, currently we have line girder and grillage analysis. So we are adding 3D finite element analysis on top of that, not only for eye girders, but also for top girders. We also add design check for top girders, as in the case of eye girders. We also have some minor enhancements, such as option to specify bracing of concrete and case top flange and detailed camber table diagrams. I'm going to explain each of them one by one. So, top girder modeling is a big and new feature we added in this release. With this enhancement, you will be able to model single top girders and multiple top girder bridges with an alignment of curved or straight alignments. You will be able to model transverse longitudinal stiffeners, internal and external cross frames, and top flange leather bracing members and more. Also, you will have the option of defining single or double bearing for the top girders. So from here on, I'm going to introduce some graphical user interface changes made to the program due to the top girder enhancements. So under member groups dialog, under member type on the right top corner, you will have eye girder and top girder alternatives. And by selecting top girder, from there on you can define your framing plan. The next one is the member definition, where you define your members. Under top girder, after the top girder selection in the member groups, this dialog box will be available under member definition. You will have bottom flanges, webs, and top flanges to be defined. And on the bottom right corner, you will see a nice sketch of what you defined up there, as in the case of eye girders. Also, in the cross frame diaphragm locations dialog box, now different from eye girders, you will have two types of cross frames, internal and external. External cross frames are in between top girders, basically connecting top girders. Internal cross frames are within the top girders. And in the sketch below, you can see what you defined up there. Under the internal cross frame type selection, you can also define top flange lateral bracings with the sections you defined previously. Also, on the very right-hand side, you can see top flange lateral bracing orientation. You can change its orientation as well. The last change in the graphical user interface for top girder modeling is the bearing and beam seats. For top girders, you will have the option of defining one or two number of bearings. And for each support location, you can define different number of bearings. For example, for support 1, you can select to have 1 bearing, and support 2, you can select to have 2 bearings. So here I'm going to show you a short demo of what I just described. When you go to the member groups, you can see the framing plan, and under the member types, you can select either eye girder or top girder. And under member definition tab, you have the elements of bottom flange, webs, and top flanges to be defined. And on the bottom right corner, you see the dimensions. Under cross frame locations, you have two options of cross frame types, external and internal. And what we define up there, you can see it in this sketch at the bottom. For internal cross frames, it's similar. But you also have the option of defining top flange lateral bracing members. Lastly, we have bearing beam seats. As I mentioned, you can define 1 or 2 bearings per top, and for each support location, you can have different number of bearings. So now let's take a look at how it looks. You can see 4 top girders with external cross frames here. You can see the internal cross frames at the end. So the next major enhancement we added is the 3D finite element analysis. With this option, you will have more accurate analysis results compared to line and grillage analysis. So for the graphical user interface changes, when you click on Analysis tab, on that dialog box on the top left corner under Analysis Options, currently you have line girder and grillage analysis options, and we added the third one as finite element. Also, we added another dialog box down below where you can define the FEM meshing settings so that you can change if you're meshing to be coarser or finer. And finer meshing size meaning the more accurate analysis results, but the longer analysis time, so that you can change the settings according to your needs. As some of you know, we in Liquid Steel, we are using STAT Pro engine and STAT Viva, and top girder analytical model will look like these screenshots in the STAT model. You can see internal cross frames, external cross frames, stiffeners. And for eye girder, you will see on the left-hand side, that's how it will look for the analytical model. And on the right-hand side, it's just a representation of how a deflection diagram is going to be presented and a moment diagram is going to be presented. So I'm moving on to the minor enhancements we have. The first one is the option to specify bracing of a concrete encased top flange. Basically, in the current version, when a beam is defined as non-composite, the top flange of the beam was not continuously braced. It was discretely braced. So we added this option, and when this option is checked, even the girder is non-composite, the top flange of the beam could be continuously braced for the design check. The next minor enhancement we have to the Camber tables and diagrams. Currently, we were only showing the Camber values due to deflection of the beams. However, in this release, we added the contribution of the geometric camber, which is due to the vertical curvature of the profile. Also, we added some other geometric information as well for the beneficial for the design plans, such as top of pavement elevation, top of form elevation, and blocking offset. That will conclude my presentation. I'll be glad to answer your questions, but before I move on to that stage, I'd like to open a poll. And if you would like to be contacted by a salesperson, if you're interested, please vote it accordingly. I'll just leave it open for maybe 30 seconds or so. Okay, thank you very much. Now, please feel free to ask questions. You can type your questions in the chat window. It can be related to the new version we are releasing, or it can be a general question related to Liquid Steel. Ali Omar is, I guess, getting prepared to ask a question. As well as you. Okay. Ali Omar's question is related to some combined type of bridges. Pre-stressed concrete and steel girders can be used in the same bridge in different spans, I guess. He's asking if it's possible to combine both materials in one model. Fortunately, we cannot do that at the moment, but that's also in our plan to create such models to cover that type of bridges. But you can also solve one span in, for example, pre-stressed concrete span using lip-bridge concrete and solve the steel span using lip-bridge steel. I don't see any reason why you cannot do that.
So Ali, as far as modeling is concerned, that is possible to do in OpenBridge modeler right now. You can mix pre-stressed girder and steel girder bridges in one model. However, right now only steel bridge goes to deep bridge steel, and concrete bridge can go to deep bridge concrete for analysis. But we will consider it's a very good suggestion, and we will consider and do have plans to offer that feature.
And Michael Arpino has a question about the torsion. How is that being handled? For the finite element modeling, the torsion is, since it's a 3D model, torsion is being created by just the model itself, and we are only reading the values. For the grillage model, we are actually following NCHRP 1725 enhancements about the using J values for the cross frames. But for finite element modeling, 3D finite element modeling, it's not an issue. Thank you for the question. Okay, Steve is, I guess, preparing another question for us.
So Steve, you're asking a question about how does Lee steel compare with MDX. Frankly, we haven't done a one-on-one comparison. However, we believe what we are offering in Lee Bridge Steel is going to satisfy majority of your needs for analyzing, modeling, designing, and even load rating steel eye girder bridges and tub girder bridges.
In addition to that, I believe MDX is not using plate elements. So what they have is called 2.5D model. However, we are using plate elements for the bottom flange and the webs of the top girder. So I believe that ours is real 3D model of the top girders. Nina, regarding the PowerPoint presentation for today, we are recording this meeting, and it will be available for you.
And guys, if you need a copy of today's presentation, please write back to Burak. His email was shown, and he will flash it again on the screen, and we'll be glad to send you a copy of today's presentation.
Vince have another question. Will cross-frame member forces be available when using 3D FEM analysis? Yes, definitely. And this will be the real member forces in 3D finite element analysis, as opposed to using an approximate methods in Girder analysis, where you represent the cross frames with just one line, and then you distribute that load to the different individual cross frame members. In 3D finite element members, it will be much more accurate. Is there any other questions? Okay, I guess there's no other questions. I don't know if everybody is looking at the chat window, but Patsy has some announcements there. Let me read it for you. Some of you may be participating today under another person's login. All persons may receive learning credit. After this session, the attendee who logged in will receive it. Tell us what you think email. At the bottom of that email, the list of participants option can be used to add attendees. Within 7 to 10 business days, attendees should be reflected to the respective Bentley transcripts. So, thank you very much, everybody. Hope to see you in the next SIG meeting, and have a great day.
If you found this video helpful, please give it a like. If you want to see more such series, consider subscribing to our channel. Thank you, and see you next time.